In this video, we're going to talk about solving equations that have radicals in them, and also equations that are in quadratic form. So they're going to be similar to the ones we did in section 1.2, except so they have that form, except that maybe it's not just x squared. Okay, so it might be something more complicated squared, but it's in that sort of same ax squared plus bx plus c form. But let's do the radical ones first. So when you have an equation with a radical, so a root of some kind, here are some examples. Okay, so the first two involve square roots, whereas this last one is a cube root. You want to apply the following sort of method. So the first thing you want to do is isolate the radical on one side of the equation. So if there's more than one, then you can choose one to isolate on its own, or you can put them together on the same side. Now, if the radical is a square root, you're going to want to, once you have it isolated, you're going to want to square both sides of the equation. Okay, if it's a cube root, then you're going to want to cube both sides of the equation in order to eliminate it. And then you want to solve the remaining equation. So if there's more than one radical, you might need to repeat these steps. So you might, once you square both sides, you might still have radicals, and then you want to isolate them and then square both sides again. Now, one part of this, the last step of this, is to check your solutions. Okay, this is very important here. We often get extraneous solutions. Okay, so you want to make sure that you check your solutions. So here's an example, just to walk you through the steps before we do a full example. So here's my equation. I have root x plus 5 equals 0. So I'm going to isolate the radical. So I subtract 5 on both sides. Maybe I should just write this. Subtract 5 on both sides so that they disappear on this side. So I have now root x equals negative 5. Now I'm going to square both sides. Okay, so then I get x equals 25. So this is what I think my solution is. Okay, but then I check it. So when you check, you plug into original equation. Okay, so notice we plugged it into this equation up here. So we have the square root of 25 plus 5 equals 0 is what we're checking. So here, that's actually, so square root of 25 is 5. So we have 5 plus 5 equals 0. Well, that says that 10 equals 0. Okay, so that means that x equals 25 is extraneous. So in fact, this equation has no solutions. So it didn't satisfy the original, so there actually is no solution. Okay, it's not uncommon when you're solving radical equations to obtain extraneous solutions. Okay, so you need to make sure that you're checking your answer. This happens because when you apply the even power, okay, so you squared both sides, you open up this possibility. Okay, so as I just mentioned, to determine which equations are extraneous, you're going to want to plug each solution into the original equation. Okay, and see if it makes sense. Okay, so if you get something silly like 10 equals 0, then it doesn't make sense, so it's extraneous. So let's actually solve one. So I'm going to do number 1 here. Okay, so we see that I have negative x plus the square root of 15 minus 2x equals 0. So the first thing I want to do is isolate my, my square root. Okay, so I'm going to add x to both sides, okay, so that it gets rid of it on the left. Okay, so that's going to give me square root 15 minus 2x is equal to x. Okay, now I want to square both sides. Okay, so that's going to give me the square root and the square cancel. So I get 15 minus 2x is equal to x squared. Now I just want to solve the resulting equation. Okay, so what I can do is put everything to one side. So I'm going to put it to the x squared side. So that means I'm going to add 2x to both sides and subtract 15 to both sides, so that I have 0 is equal to x squared plus 2x minus 15. So now I want to factor this. So I want two numbers that multiply to give negative 15 and add to give 2. So that's going to be x plus 5 and x minus 3. Okay, so I get 0 equals x plus 5 times x minus 3. So then, using the zero product property, this means that x plus 5 is equal to 0, or x minus 3 is equal to 0. And then if I solve, so I subtract 5 on both sides, or add 3 on both sides, I'm going to get x equals negative 5, or x equals 3. Okay, so those are my possible solutions. And now over here, I'm going to check that they work. So let's check x equals negative 5 first. So I plug that in, so I'm going to have negative 5. So I'm plugging it into this original equation. Okay, so everywhere I see an x, I'm going to put in a negative 5. So negative 5 plus the square root of 15 minus 2 times negative 5. That should equal 0. So negative 5 is 5. And here I'm going to have 15 plus 10, so that's going to be 25, is equal to 0. Okay, so that gives me 5 plus 5 equal to 0. Obviously, this doesn't make sense. Put an x. Actually, maybe x is confusing. Let's just put some question marks because that's not true. Okay, so that means that x equals negative 5 is extraneous. Okay, now we want to check x equals 3. Okay, so it's possible that they both are extraneous. So I have negative 3 plus square root of 15 minus 2 times 3. And I want to know, is that equal to 0? So that's negative 3 plus square root of 15 minus 6 is square root of 9. So that's negative 3 plus 3 equals 0. That one's true. Okay, so that one makes sense. So that means that our solution set is just the set containing the number 3. Okay, so we had to get rid of the 5 because it was extraneous. Okay, I'm going to leave number 2 for you to do, but remember, so there's 2 radicals, so you want to isolate for one of them, or you can actually do it when it's like this if you want, and just immediately square both sides, but you're probably going to have to do it twice. Okay, so you might have to go through the method more than once, so don't let that freak you out. Okay, so I want to do one that's not a square root. So here I have one that's a cube root. So 2 times the cube root of 4x minus 1 is equal to 6. So I'm going to start by isolating the cube root. So I'm going to divide both sides by 2. Okay, so that gives me the cube root of 4x minus 1 is equal to 3. Okay, now we cube both sides to get rid of the cube root. So then I'm going to have 4x minus 1 is equal to 27. And now I can just solve. So now I'm going to isolate the x. So add 1 to both sides. So I get 4x is equal to 28. And then divide by 4. And I get x equals to 7. Okay, now we should check that this makes sense. So we plug that into the original. So I have 2 times the cube root of 4 times 7 minus 1. And we want to know, is that equal to 6? So that's 2 cube root of 28 minus 1 is 27. Okay, now the cube root of 27 is 3. And 2 times 3 is equal to 6. So that works out. So we have the solution set is the set containing the number 7. So 7 is, in fact, a solution of this equation. Okay, so sometimes there are equations that are quadratic in nature without actually being quadratic. Okay, so for instance, here I have an equation like this. So the power is a power 4. Okay, so it's not a quadratic equation. Quadratic equations have highest power 2. Okay, but we can use similar techniques to factor it. So because I have only x to the 4 and then x squared in my equation and no other x's, what if I just do a change of variables? So let's say that I let u equal to x squared. Okay, then u squared is x squared squared, which is going to be x to the 4. I'm just going to write that underneath. So this is x squared squared. Okay, so that's why we get x to the 4. And then so my quadratic equation, so the original one, is actually going to be, instead of x to the 4, I'm going to have u squared. Instead of x squared, I'm going to have u. And now see that it looks like a quadratic, and we know how to factor this. Okay, so I want two numbers, okay, that multiply to give -5 and add to give 4. So that's going to be 5 and -1. Okay, so then u squared plus 4u, minus 5 equals 0. I can factor as u plus 5 times u minus 1. Okay, so that means, using the zero product property, that u plus 5 is 0, or u minus 1 is 0. So then I get u is -5, or u is equal to 1. And now I want to sub x back in. Okay, so remember u is x squared. Let me just write this. But u equals x squared. So this is actually x squared is equal to -5, or x squared is equal to 1. Now when you have a square equaling a negative number, that does not make sense. Whenever you square a number, you always get a positive number. Okay, so this does, this has no solutions, since x squared is always at least 0. Okay, so it can't be negative. But over here, we're going to get x equals, so I take the square root of both sides, so this is the square root property. It's going to be plus or minus 1. Okay, so those are my solutions. I'd want to check them. Okay, so let's check x equals 1. So if I plug that into the original, I have 1 to the 4 plus 4 times 1 squared minus 5 equals 0. So that's 1 plus 4 minus 5 equals 0. That's true. And if I check negative 1, I have negative 1 to the 4 plus 4 times negative 1 squared minus 5. And I want to know, does that equal 0? Negative 1 to the 4 is 1. Negative 1 squared is also 1. So this is plus 4 minus 5. And that one is also true. So here, the solution set contains the numbers negative 1 and positive 1, seeing as they're both valid solutions. Okay, so I'm going to leave this one for you to do. It's also in quadratic form. Okay, but you're going to have to figure out what to substitute. So pick a u so that this term is u squared and this term is u. Okay, and then you can use the same idea. Okay, so we can also do other things. So this is solving other equations by factoring. In fact, this one is also, this one is also one that's in quadratic form. Okay, so here we have some options. So let's do them in different colors. Okay, well, we can do one in purple. So there, we can use the quadratic form technique, or there is this, you can also clear the fraction. So I'm going to leave that one for you to try, and we'll do the quadratic form technique this time. So for the quadratic form, what I'm going to do is I'm going to rewrite this. Okay, so this is 1 is 1 squared, right? So I could write the first term as 1 over x minus 2 all squared. Okay, now in the second term, I could pull out the 3. So it's like 3 over 1 times the other thing. So then it's going to be times 1 over x minus 2. And that's going to be equal to negative 2. Or actually, let's just, I'm going to move it over. So if I add 2 to both sides, then it's gone on this side. So then I'm going to have plus 2 equals 0. And now maybe we can see that I have something squared minus a number times the same thing. This is a quadratic form. So if I let's let u equal 1 over x minus 2. Okay, then I can rewrite this as u squared minus 3 times u plus 2 equals 0. So now I want two numbers, okay, that multiply to give positive 2 and add to give negative 3. So both the numbers are negative. It has to be negative 2 and negative 1. So this is going to factor as u minus 1 times u minus 2, which means that u minus 1 is 0, or u minus 2 is 0, which means that u is equal to 1, or u is equal to 2. Okay, now I actually want to solve for x. So that means that 1 over x minus 2 is equal to 1, or 1 over x minus 2 is equal to 2. Okay, so then we want to solve this. So how do we solve this? Well, we could multiply both sides by x minus 2. So we actually can do that to all the things. So then that's going to give me a 1 on the left-hand side. And on the right-hand side, I'm going to have just x minus 2. This side, I'm still going to have a 1 on the left, but now I have 2 times x minus 2. Okay, so if I add 2 to both sides, this one tells me that x is equal to 3. And over here, this is 1 equals 2x minus 4. So I add 4. So that's going to be 5 is equal to 2x, or x is equal to 5 over 2. Okay, so I get these two different values. And then we want to check them. So if I plug in x equals 3, okay, I want to plug into the original. So it's 1 over 3 minus 1 squared minus 3 over 3 minus 1. Sorry, 2. I'm getting ahead of myself. Okay, is that equal to negative 2? So this is 1. 3 minus 2 is 1, so this is 1 squared. So this is 1 minus 3 over 1. Okay, that is equal to negative 2. Okay, now what if we check 5 over 2? So that's 1 over 5 over 2 minus 2 all squared minus 3 over 5 over 2 minus 2. And we want to know, is that equal to minus 2? So 5 over 2 minus 2, so that's 4 over 2. This is going to be a 1/2 squared. Okay, now over here I just have the 1/2. 1/2 squared is 1/4. So if I flip and multiply, this is 1 over 1 times 4 over 1. And this is going to be 3 over 1 times 2 over 1. Oops. We want to know, is that equal to negative 2? Okay, so this is 4 minus 3 times 2 is 6. And that, again, is negative 2. Okay, so here we have the solution set. Contains both 3 and 5 over 2, or 2.5 if you prefer. Okay, now remember, we're going to also you should try this doing it the other way. Okay, so, and the other method was to clear fractions. Okay, so I would encourage you to try that method, and then you can compare when I fill it in later. You should get the same 2 answers though. Okay, so this one is similar. Now when you clear fractions, you just want to be aware that, that this creates also the possibility of extraneous solutions. So you definitely want to check still when you are clearing the fractions. So remember, you can only multiply by like x minus 2 or x plus 1 here if that thing is not 0. Okay, so you want to be careful about that. So actually I'm going to leave both of these things for you to try. And I want to talk about this one here. So here we want to solve this equation. Now this one is not in a quadratic form, okay, because, so this one does look like it's something squared, but there's an extra x here. And this thing is not the same thing because it's negative exponent. Okay, so this is not a negative thing squared. So what we want to do is use our old sort of tricks. Okay, so there's a common factor here. Okay, so either you could, so maybe I'll say method 1, pull out common factor. Okay, or you could, method 2, get rid of negative exponents first. Okay, and then you'll have to work with fractions. So again, whatever method you prefer, maybe I'll do method 2 this time. And hopefully I have room for the other method. So if I do that, get rid of the fractions first, so what's going to happen is that x minus 8 to the negative 1/3 is 1 over x minus 8 to the positive 1/3. Okay, now here I have plus x times x minus 8 to the 2/3. And that should be equal to 0. So this is like over 1, so I want to make a common denominator. So I'm going to times this one by x minus 8 to the 1/3 over x minus 8 to the 1/3. Okay, so what that's going to give me is I have 7 over x minus 8 to the 1/3 plus, so then I'm going to have the x still, and then x minus 8 to the 1/3 times x minus 8 to the 2/3. Remember, I want to add the exponents because it's the same base. So that means it's going to be x minus 8 to the 3/3, which is actually x minus 8 to the power 1. Okay, over x minus 8 to the 1/3. Oops, and that should be equal to 0. So now I have just one fraction. Okay, so that's going to be 7 plus, I'm going to expand this, so it's x squared minus 8x. Okay, now when you have a fraction equaling 0, this is true so it's going to be equal to 0 when the top is 0. Okay, so I'm going to rewrite this in the right order here. Okay, so maybe let's just make a note of that. Fraction equals 0 when top equals 0. And I should make a note that the bottom should not also be 0 at that time. Otherwise, it's not actually a solution. So we want to factor this. So I want two numbers that multiply to give 7 and add to give negative 8. So that's going to be negative 7 and negative 1. So that means that x minus 7 equals 0, or x minus 1 equals 0, which is x equals 7 or x equals 1. Okay, and it turns out that both of these are solutions. Okay, so just to save time, I'm not going to do that, but I'm just going to make a note. You should check this. Okay, for practice. So yeah, make sure that you check that those both work. And you can also do method 1. Okay, so I tried to leave some space here for method 1. Okay, so that's clearing the fractions out, or sorry, pulling out the common factor. So you would start by pulling out x minus 8 to the negative 1/3. Okay, so this is similar to something we've done before. So you hopefully should be able to do that. And for number 9, I'll leave this one for you as well, but be careful. So it's tempting. Okay, so maybe that's right over here. So careful on this one. It's tempting to divide both sides by x, or x cubed, in fact. Okay, but you can only divide both sides by x, or x cubed. Maybe I'm just going to say x, okay? If x is not equal to 0. Okay, so that you want to be careful about that. So if you are missing a solution and you did it this way, this might be why. Okay, so keep that in mind. There's a different way to do this question where you don't need to do that. Okay, so I would encourage you not to divide both sides by x of any power. Okay, but if you do, you can still get the answer if you remember this hint. So that's solving some equations involving radicals and also equations in quadratic form.